Hello again. Today we are moving on to a slightly new topic. I'd say slightly new because we've seen some of this stuff before. We did some piecewise functions earlier in the year, and this is going to be related to that topic. The topic is called limits, and again, a very important topic in calculus. So first off, the definition. We say that the limit of f of x as x approaches a is equal to L. So essentially what we're looking at is a graph that might have some jumps or breaks in it. And we're looking at what's happening as the x value is approaching a certain number, what's happening to the function. All right, so it's called a limit. It's important to see the notation, the word limit, and then underneath x with a little arrow approaching a means as x is approaching a. And again, if it doesn't make any sense, we'll do an example in a few minutes and it'll make more sense then. All right, is equal to L. All right, so essentially what we're doing is we're trying to make the values of f of x as close to L as we can without being exactly at a. So again, with a picture and an example, I think things will make a little bit more sense. But some of the notation here is what I want you to see. All right, now, it's a little slightly different type of limit. It says, we say that the limit of f of x as x approaches a from the left is equal to L. And I want you to notice again the key point right there, that x approaches a and then the little minus sign, that means from the negative direction. So again, if you're thinking about a graph, you've got a graph and it could be any kind of crazy graph. It's moving and then here it jumps and then it goes to there and then over here it does this thing and then it jumps again and moves to here and then down here it does that. So again, doing all kinds of weird stuff happening. So what we're talking about is, let's just say this is point A. We want to know what is the limit as x approaches A from the left. That means if you're coming towards A from the left, that means you're coming along this direction. Where are you right as you can, where are you at A, but as you're approaching A from the left, if this was numerical, you would say that that limit would equal 2. As you're approaching A from the left, that's about where we're at. All right? Hope that makes a little bit of sense. All right, now the second part of that, the opposite kind of thing from that, is when x is approaching A from the right. So the limit of x approaches A from the right, you'll notice this next one here has that little A with a plus sign on it. Meaning, again, we're coming from the right-hand side. So if I was doing that on this one, looking at A from the right, I'd be talking about coming towards A from the right-hand side, reversing things, and that would take me to this spot. Answer wouldn't be 2 anymore, the answer would be 1. All right, so again, it depends on which direction you're coming from. All right, so that's important. All right. A couple other little things on here. All right, so right here, limits taken from the left or right are called one-sided limits. That's what we just talked about, the one-sided limit, from the left or from the right. All right, now, a function is considered continuous at x, or at a certain point, if the limit from both sides is equal. All right, so if we have a function that's continuous, meaning that, again, for example, back to this spot, right here, the function is continuous at that spot. It doesn't jump. Right there, not continuous. Right here, not continuous. But right there, it is continuous. And then one of the ways to tell, again, is if it has an actual value. All right, if the function has a value, another idea and a way to tell, again, is if those limits are equal to each other. So if the value of a limit equals the value of the function, then we can say that it's continuous. There's no breaks or holes there. But if the value of the function is different than the value of the limit, then we have discontinuous. Those are our jumps, called discontinuous. All right, I'm going to make a separate video with an example because this one's getting a little bit long-winded here. So there'll be a second video showing you how to do the work today in case this didn't make any sense.